This is Bob Capetta, and this lesson is on compound inequalities. So let's see if we have something like this. X is less equal 5, and x is greater than 2. How do we express this? And, of course, means intersection. So in the case of an intersection of two streets, you've got to be on both streets at the same time, as we see the intersection of two roads. So this is going to be a solution where both things are true simultaneously. X is less equal to 5 and x is greater than 2. So let's make sure our order is good. 2 is here. 5 is here. X is greater than 2, so I need an open circle at 2. X is greater than 2, so that means it's heading that direction. X is less than or equal to 5, so that will be a solid circle, therefore less than or equal to, and it is headed that direction. So the question then is, where are both of them true simultaneously, and what's the intersection of those two sets? Where are they both true? Again, there we see it. We see the intersection of two streets. X less equal 5, x greater than 2. Where are they both true simultaneously? That, of course, would be in the middle. So my answer on the number line is this. So we have a round bracket at 2, comma, a square bracket at 5. From 2 to 5 is what we would work with there. Starting with x less equal 5 and x greater than 2. What if we had this? What if we had x is greater equal to and x is greater than -7? Again, we're going to look at this and we're going to ask ourselves, where are both true simultaneously? So we draw our number line. -7 comes first. 2 comes second. Greater than, open circle. Greater equal, solid circle. Now, which directions are these going? X is greater than -7, so we're going to shade everything to the right. X is greater than -7. X is greater than or equal to 2, so we're also going to shade everything to the right of 2. And means what? Means I want to shade both of them simultaneously. Again, and means intersection. Where are they both true simultaneously? Just on this bit right here. So an interval notation that will give me the interval square bracket 2 plus infinity is how that's going to work. You can also have a situation like this, where I say x is less than 1 and x is greater than or equal to 5. And you can see 1 is here, 5 is here. Less than 1 would shade this way. Greater than 5 would shade that way. And means it's got to be in both sets simultaneously. Intersection, again, intersection of two streets. What's on both streets simultaneously? There's nothing. There is nothing that is both less than 1 and greater than or equal to 5 at the same time. So this has no solution. Or you could say empty set. Sometimes you write it this way, sometimes you write it this way. So those are various ways to explain that there is nothing that is going to work in that regard. So that's how the ors work, or excuse me, the ands work. We'll look at the ors now. If I have x is less than 2, or x is greater equal 5, or a union. You're either in the first set or the second set or both. You belong to that union. So we're going to go ahead and lay out our number line. Here's 2, here's 5. Less than 2 is going to shade this way. Greater or equal to 5 is going to shade that way. Again, I will use my open circle here for less than. I will use my Closed circle there for greater than. Or means either in one set or the other set or both. So we're going to get this, and we're going to get this. In interval notation, what will that be? Negative infinity, comma 2 round bracket, union, square bracket, 5 to plus infinity. That's what that is going to look like. Now, of course, these can get more interesting. If I say x is greater or equal 1 or x is greater than 7, what's that going to be? Here's 1. Here's 7. X is greater or equal 1, which means we shade that way. X is greater than 7, which means we shade that way. So you might say this should be an open circle. This should be a closed circle. You've got to be in one set or the other or both. So this is in one set. This is in the other. But the thing to recognize is that 7 also gets colored in because that is up here, right? 7 is part of the solution set to x is greater or equal to 1. So on my number line, it's everything larger than 1 in this case. So we'll say square bracket, 1 to plus infinity. Round bracket, because of course we never actually get to infinity. So that's what that means. And, you know, we could have more complicated ones than that, but that basically gets at the notion of the ors versus the ands. Now, when we layer these together, for example, if I say negative 1 less equal x plus 2 less 7, what does this really mean? What does this really mean? It really means negative 1 is less equal x plus 2 and x plus 2 is less than 7. So you know the way I like to do this, I like to solve it as an equal and then test numbers to see where I have to shade. So if I'm going to do it that way, I'm going to say x plus 2 equals negative 1, subtract 2, x is negative 3. So which way do I shade on the negative 3? Negative 3 is here. It is a solid dot. I have numbers on each side. To the left of negative 3 might be negative 4. To the right of negative 3 might be 0. If I plug 0 in, 0 plus 2 is 2. Is negative 1 less equal 2? It is. So that's going to be shaded that way, to the right of negative 3. If I plug negative 4 in, negative 4 plus 2 is negative 2. Negative 1 less equal negative 2. No, it is not. So that's that piece. Over here, again, x plus 2 less 7. I like to do it as an equal. X plus 2 equals 7, subtract 2, x equals 5. Lay out the number line. It's an open circle this time. And I have numbers on either side. To the left of 5, I might choose 4. To the right of 5, I might choose 6. Are they yes or are they no? Maybe I can do this mentally. Plug the 6 in. 6 plus 2 is 8. Is that less than 7? No. Plug the 4 in. 4 plus 2 is 6. Is that less than 7? Yes, it is. So I'm shading this way. But it's got to be an and. So I need to shade the part that is true for both simultaneously. So I lay out my number line like this. Here's negative 3. Here's 5. Remember, negative 3, we shaded this direction. 5, we shaded this direction. Where are they both true simultaneously? That would, of course, would be in the middle. Negative 3 had a solid dot here. 5 had an open dot there and in the middle. We're going to shade it like that. So what is that in interval notation? Square bracket, negative 3 to 5. Now I'm focusing on concepts here, friends. You can shortcut this, but be careful when you shortcut it. Let me show you what I mean by that. So I will do the more traditional textbook approach now and say negative 1 less equal x plus 2 less 7. So here's the textbook approach. Right. Subtract 2, subtract 2, subtract 2. Then you ask yourself, do you change the sign if you subtract from both sides? No. But that's where students often get confused. So I get -3 less equal x less 7 minus 2 less 5. X is between -3 and 5. -3 is here. 5 is there. Solid dot here. Open dot here. We get an answer. And you might say, that looks pretty good. That was fast. No doubt about it, it was fast. But there's a lot of places you can mess up. So let me show you what I mean by that. I will do the textbook method for one that's going to be more challenging. So if I say -2 is less than or equal to -3x plus 7 is less than 13. First thing to notice is -2 is less than 13, so that's good. If that was not the case, we're going to have an awfully difficult time doing this problem. So if we're going to use the textbook method, subtract 7, subtract 7, subtract 7. -2 minus 7, -9 less equal -3x less 13 minus 7 is 6. Now what do I have to do? Now I've got to divide by -3. -3x divided by -3, -9 divided by -3, 6 divided by -3. But if I do that, I have to switch the signs. That's what gets dangerous. So I have -9 divided by -3 is +3, greater equal x, greater 6 divided by -3 is -2. Now do not write a number line with 3 on the left and -2 on the right. That's out of order. So I'm going to rewrite this with -2 first, 3 second. X is greater than -2, so -2 is less than x. 3 is greater than or equal to x, so x is less equal 3. So if we use the textbook approach, we've got to be careful. This then will be our final answer. We will have -2 here. We will have 3 there. Round circle, excuse me, closed circle, open and closed. Everything is in between. It gets us our answer that way. But again, I really want to make sure you don't turn your brain off, because there can be some of these problems that if you're thinking about it, you can save yourself some time and some aggravation. For example, if I say 5 is less than x plus 1 is less than -8. If you try any kind of a textbook strategy, or frankly any strategy, you're not going to get very far, because this number in the middle has got to be bigger than 5 and simultaneously at the same time be less than -8. How could you be both bigger than 5 and less than -8 at the same time? That can't happen. So I don't have to do any work here. I can look at this and immediately say that this is no solution. But if you tried the textbook method, what are you going to get? You're going to subtract 1, you're going to subtract 1, you're going to subtract 1. You're going to say 4 is less than x is less than -9. And what does this mean? What does this mean? This means 4 is less than x and x is less than -9. What does this mean? If 4 is less than x, that means x is greater than 4 and x is less than -9. They both have to be true simultaneously at the same time. Draw your number line. Make sure -9 comes first. Make sure 4 comes second. Where are they both true at the same time? X is less than -9, shade that way. X is greater than 4, shade that way. Where are they both true? And remember, intersection and. Where are they both true? Never. No solution. So try to think about what this stuff means. I think that's helpful. It gets challenging, no doubt about it. But stay engaged. Ask yourself, does it seem reasonable? That will save you a lot of work and a lot of consternation in the future. That'll end this lesson.